Welcome to Chakra International. I'm Nilamadana speaking. This is related to material science, engineering, and standard quality practices. The main objective of maintenance to optimize the equipment and infrastructure reliability, to see the equipment and infrastructure kept in good operating condition, to ensure prompt emergency repair, to ensure productivity of existing equipment, to improve the safety at work, to train personnel for specific maintenance kit, to advise the management acquisition and installation, and to help to manage and guarantee finished product. The various type of maintenance, reactive maintenance basically run it till it breaks. Maintenance mode, no action, no effort are taken to maintain the equipment as the designer originally intended to ensure design life is reached. Note that as per the study, almost 50% maintenance resources and activities of an average facility will still reactive. Advent to reactive maintenance can be viewed as a double-edged sword. And then the advantage is the low cost, less staff. Disadvantage, increased cost due to unplanned downtime, increased labor cost and cost involved. Preventive maintenance can be defined as action performed on time, action performed time or machine on best schedule that detects, preclude, mitigate degrading of a component or system with the aim of sustaining or extending its useful life through controlling and degradations. To an action aims to increase the reliability of equipment by simply spending the necessary resources to conduct maintenance activity intended by the equipment designers. Advantage of cost effective in many capital intensive processes. Flexibility allows for the adjustment of maintenance periodicity, increase the component life cycle, energy saving. Main purpose of preventive maintenance is to prevent a delay failure. The predictive maintenance can be defined as a measurement that detects the onset of system degradations, thereby allowing the causal stressor to eliminate or control prior to any significant deterioration in the component physical. Result indicate the current and future functional capability. Basically, predictive maintenance differs from the preventive maintenance by basing maintenance need on the actual condition of the machine rather than on some preceded. Advantage, increased component operational life availability, allow the preemptive corrosive action, decrease in equipment and process downtime, decrease in cost per part and level, better product quality, improved workers and environmental safety, improved worker moral, energy saving, and estimated 8 to 12% cost saving. Despite increased investment, diagnostic may increased investment, staff training. Reliability center maintenance may be defined as a process used to determine the maintenance requirement of any physical asset. Any physical asset in its operating constant. Reliability center maintenance RCM method deals with some key issues not dealt with by other maintenance programs. It recognizes that all equipment and facility is not of equal importance to either the process or facility safety. It recognizes equipment design and operation differs. The different equipments will have higher probability to undergo failures from different degradation mechanisms from others. It also appraises structuring the maintenance program. I recognize that the facility does not have unlimited financial and personal resources and that use of both need to prioritize are optimized. Now, RCM approach to utilize the available maintenance approaches with the predominant methodology being predictive, less than 10% reactive, 25-30% preventive, 45 to 50% predictive. Total productive maintenance focus on keeping all equipment in top working condition to avoid the breakdown or delays in manufacturing process. TPM is a holistic approach to equipment maintenance that strives to achieve perfect production with no breakdown, no defect, no accidents. The failure mode effect analysis, the most important failure mode effect analysis. It involves reviewing as many components, assemblies, and subsystem as possible to identify the failure modes and their causes and effect. For each component, the failure modes and their resulting effects on the rest of the system are recorded in a specific failure mode effect analysis worksheet. These are the numerous variations of worksheet. Failure mode effect analysis is a structured approach to discovering the potential failure that may exist within the design of product and process. The failure mode are ways in which the process can fail. Effects are ways in that these failures can lead to waste, defects, harmful outcome for the customer. Failure mode effect analysis is designed to identify, prioritize, and limit these failure modes. Reliability engineering emphasizes dependability in the life cycle management of a product. Dependability and reliability describe the ability of a system or component to function under stated condition or a specified period of time. Mean time to failure is a basic measure of reliability for non-repairable system. It is a mean time expect until the first failure of a piece of equipment. Mean time to failure is a statistical value. It means to be the mean over a long period of time over a large number of units. For constant failure rate system, mean time to failure is the inverse of the failure rate. Quality assurance is referred to as a scheme adopted by a construction company to maintain the standard of quality consistent with primarily internal management system of a construction company. Generally, a company maintains quality assurance chart by specifying the various checks at different levels as well constantly improving its attributes. A quality assurance program may include arranging periodical training, good safety program, a sound procurement system to get best quality, and the company involved. If a company involves repeated work, then implementation of statistical control process such as concreting regular sampling scheme control the production. Quality control is a periodic inspection to ensure that our construction facilities meet the standards specified in the contract. Total quality management is a system continuously improving the goods and services. TQM approach is considered essential to long-term survival of the business such as construction. Five gaps of service quality model: gap between expectation of customers and perception management, gap between perception management and services of quality specification, gap between specification of quality and the delivery of service, gap between the delivery of service and external communication, gap between the perceived and expected service. This is the material science chemistry. Joseph junction is a device having two superconducting plates separated by oxide layer. These junctions are used in speed superconducting quantum interference devices, computer memories, and other microelectronic devices. Magnetic levitation. This is a levitation phenomenon caused by opposing magnetic fluxes. The use of this is in wheel-less high-speed trains that are equipped with superconducting magnet. Magnetohydrodynamics. It deals with the motion of electrically conducting fluid under the influence of magnetic field. This principle employed MST power generation, MST ship propulsion, MST magnet. Magnetic resonance imaging. The visual image of the brain and other body parts can be created. Superconducting magnets above 2T are suitable for this purpose. For each type 2 superconductor used. Suspension system motor. Frictionless suspension system may be found by the interaction between a magnetic flux produced by externally and current flowing in a superconductor. Seebeck effect. Seebeck effect. When two dissimilar metals are joined at the ends, a junction ends are maintained at different temperature, then EM exists across the junction is called Seebeck effect. Peltier effect. An electric current which flows to a rod consisting of two dissimilar metals causes decrease in temperature of one end and increase temperature of the other end. It is called cause of Seebeck effect. Conductivity of semiconductor increases with the rise of temperature. The semiconductor metal do not follow Ohm's law. The number of conducting electrons per atom determine atomic structure. If more than 3 valence electrons there, both the characteristic bonding covalent ion may exist. Electrical properties change completely except T and lead. When the material having number of valence electrons Z from 2 to 8 general show superconductivity. Most important, materials having number of valence electron from 2 to 8 generally show superconductivity. Element which atomic temperature element which at room temperature good conductors are absent from list of superconducting. Example: copper, silver. In fact, the superconducting elements are relatively poor conductors at room temperature. Iron, nickel, cobalt are also not superconducting. Superconducting compounds and alloys do not necessarily have superconducting components such as lead, tin, Copper sulfide, low temperature superconductor, critical temperature less than 25,000. Mostly low temperature are metallic, and high temperature superconductor critical more than 25,000. These are ceramic type. A sulfur hexafluoride gas known to a gas having high dielectric in comparison to air. It is the non-toxic, non-inflammable. It is inert in nature. Low permeable ceramics and used in suspension insulator for high voltage lines and pin insulator for low voltage line. Leptodite type of mica unsuited for electric insulation because it is hard and brittle. Glazing is done in ceramic insulator to make its surface smooth and non-absorbent. Paper and press pads have generally been used for binding cable insulation, and asbestos while used as heat insulator. Resistivity is composed of two components. Thermal resistivity due to lattice vibration characteristics of particle substance. Residual component of this component arrays due to impurity and heat present. With this, the present copy like is, put a bell icon. Thank you.